Hello guys, welcome to this video. Today we're going to be looking at a linked list problem. It's a very simple problem, remove duplicates from a linked list. And we're going to go over the question, discuss the complexity, see how we can solve it on a whiteboard and then write some code. Let's dive into this. Let's read the question. Remove duplicates from linked list. You're given the head of a singly linked list. So it's a singly linked list whose nodes are in sorted order with respect to their values. Write a function that returns a modified version of the linked list that doesn't contain any nodes with duplicate values. The linked list should be modified in place. That is, you shouldn't create a brand new list, and the modified linked list should still have its nodes sorted with respect to their values. Each linked list node has an integer value as well as a next node pointing to the next node in the list or to null if it's the tail of the list. All right, so we've read the question. We know the example. Let's look into the whiteboard and see how we can solve this. Let me write down the example real quick. So it's 1, 1, 3, 4 is 3 times, 4, 5, 6, 6. 1 1 3 4 4 4 5 6 6. So this is the example, right? Why is it called a simply linked list? Because you see it has reference from this node to the next node. It does not have any reference to the previous node. A doubly linked list would be a linked list that knows the node next to it, also the node previous, also the previous node. It knows the next node's next and also knows the previous node, right? But this is a singly linked list, okay, and it is in sorted order, okay. And we need to remove the duplicate. So basically, okay, let's see. Here there's a duplicate. So what we can do is instead of right now it's pointing to this node, right? Instead of that, I can make it to point to the next node. And what can we do for that is we can write a code where node dot next is equal to node dot next. So that way we change the reference. And node here is what? The linked list. Right. So let's see how we can solve this. Okay. So one, we see the next one value, both have the same value. So we say point to the next to next. Okay. Then we come to 4. Now 4 next has the same value. So I'm going to make it point to, instead of pointing to this one, I'm going to make it to point to that one. Okay. So 4 still points to another 4. Then 5. Then we see 6. 6 points to this one now, but I'm going to make it to point to the next node, which is here null. So 6 becomes null, right? Now I go over this one again to see if it has any redundant nodes, right? Redundant values. Let's see. Now, is this the same? No. 3 and 4 the same? No. 4 and 4 the same. So what I do, instead of pointing to this one, I point to that one. So 1, 3, and then 4. Instead of pointing to this one, we're going to point to that one. So 5, 6, and null. Right? Now, if you see, all the redundant ones are gone, and we still have the list in a sorted order. That's what we wanted. And since in this one, we only want to be visiting, say, every node only once at max, right? Or if they're all different, then we visit every node once. That's the worst case scenario. Worst case scenario, we may not visit all of them. We might just visit a few. So the worst case time complexity would be what? O of n. Now the space complexity in this case would would be what? Or 1. Since we are not using any other data structure, right? We are not storing any values. We are not using anything, we are basically use on the side. We don't have any data structures and all this is the list, right? And we are changing elements in the same list. So that's why this is the one. So let's just look into the code and see how we can make this happen. It's a very simple problem. Future linked list problems are going to be more difficult, but this one is not that difficult. Give me 1 second. Let me just share the screen. So here, if you see, I have the same example here. 1, 1, 3, 4, 4, 4, 5, 6, 6, right? And I'm going to call this method where I'm going to write my code. Here is a sample, example of a linked list class, how we implement. We take a linked list, it has a value and it has a next node, right? Since it's a single linked list. So what I'm going to do here is, I'm going to do while linked list dot next dot next while linked list dot next. So the next one is not equal to null, right? What do? We check while linked list dot next is not equal to null. We check if linked list dot value is equal to linked list dot next dot value. If this is the case, if they are both equal, linked list dot value is equal to linked list dot next dot value. If the value is met, then what you do is you change the reference. Okay, in the dot next, change this reference to linked list dot next dot next. So point to the next to the next, point to the node next to the next. Okay, else if that's not the case, then what you do is you take a then you take linked list dot next. If that's not the case, then you do what? Linked list dot next. Linked list is equal to dot next. Okay, we change the reference to the next one because we want to check. Now let me also do one thing. What I do is I create here linked list from the program. I create a temporary list instead of using the list that we get from the linked list, right? And this temporary list I use everywhere, not my original one. And then here, and then we check the response here. Let's see. So compared to the next value, you can basically debug to better understand the problem. So if you see here linked list, right, I'll show you one example. So if you see it goes to the next reference, now next is not equal to null. Here it will compare the value. Okay. Now see in this case, right, your node was 4. It compares with the next node value. Next node value is also 4, right? So it's gonna do switch this node with the other one. Yeah. So the next node basically. So let me come here and show you. So when we started, the list was different. Now you see 1, 3, 4, 5, 6. There are no redundant nodes left in this particular program. Let me show you once again. So if you see my input node, right? Here, if you see our input was 1. Next is 1, 3, 4, 4, 4, 5, 6, 6. Okay, these are all the nodes. Now, after the processing is done, you see 1, 3, 4, 5, 6. These are the nodes. 1, 3, 3, 1, 3, 4, 5, 6, right? And this is how you solve this problem. You have a better try, to learn coding and coding these problems. The best way is just start typing, writing code. It would be a lot easier to understand. You can write your own code and try to understand if yours could be better than mine. Check the complexity. So this is it for this problem. I'll see you in the next video with a different problem. Thank you.